quick session, slightly stress for you.
Yeah, no worry, no worry.
It's okay, no?
No,
You can take extra time, relax. So we have got a lot of time for lunch. So if you want to take 15 minutes, more rest, it's fine.
okay. Okay. Okay, good morning everyone. Welcome back to the course. I hope you enjoyed the first day yesterday. Today we have a few more lectures and also tutorials, and I look forward to the program today. We have prepared, together with Pratul, prepared relevant contents for you to learn. So this exact lecture is for learning about the knowledge of PSS design, what understanding PSS design is. So expected learning outcomes are to be able to relate PSS design to especially product design, traditional product design, and also to comprehend PSS design characteristics. First of all, I want to start with some sort of basics about design research and also design practice. This picture is taken from the well-known, widely used design research methodology developed by Blessing and Chakrabarty. They say that design research mainly consists of two elements. One is understanding design activities. The other is to develop support for the design practice. So these two are completely different things, of course related, but different things from each other. So this lecture is primarily focusing on the understanding part. So the understanding means what PSS design is, and also how PSS design takes place in different environments. So primarily we are interested in how that takes place in industry, in the real situations of their daily businesses. But in research, we may sort of make a hypothetical situation and we observe that. But that is a sort of part of the research process. So our ultimate goal is to understand how PSS design takes place in industry, okay? And I would like to cite this statement by Deming. He emphasized the importance of looking into the processes and rather than the outcomes of the processes, because the processes determine the quality of the outcomes. So in order to fix the problems in the outcomes, then we need to do something on the processes, okay? So I want you to keep this in mind, because this is very sort of, this is a cornerstone for this lecture. Another thing I would like you to keep in mind in this lecture and also the other lectures in this week is the complexity of designing, especially in industry, in a real situation. So according to the authors of this article, design can be described as a multi-layered activities. So that can be viewed from different levels, starting with in the center, starting with the evidence-based decision-making. So essentially design makes decisions, right, with some rationale. But that is built upon a certain organizational setting, meaning that the decision-making needs to be translated in a certain organizational context so that the decision making is approved by the organization, right? And then design is performed by people, meaning that some personal analysis and synthesis is involved. Depending on the sector, industrial sectors, the degree of the involvement of personal analysis and synthesis will differ, but anyway, such a personal sort of activity in design is involved. So in this lecture, we will primarily address the central part, the evidence-based decision-making process, but keep this complexity in mind, how that process can be implemented in real situation, right? Another slide focusing on the importance in looking into the processes by providing methods and supports. So the first one, implementing quality function deployment, which is a method to support mainly product design. So yesterday we talked a lot about the issues and also the improvements that we observed in the 1980s. We talked about front loading and so on. So one book, by Bob King, mentioned that basically the total lead time could be halved by properly using such methods as QFD, quality function deployment. Another piece of sort of testimony from industry is from Hitachi in Japan. They sort of implemented a set of different support methods for product design, like this QFD and trees and so on. And they say that they have managed to decrease the lead time by between 40 and 60%. So these pieces of sort of evidences support the importance of proper use of support methods for design. That is, of course, applied to PSS design too. Looking into scientific literature, but such knowledge as how PSS design takes place is quite scarce. So please try to recall the two bubbles from the design research methodology. The two elements are important in design research. One is the understanding, the other is developing the support. So looking in the literature, understanding of PSS designing is quite scarce. But looking into literature, you easily find different methods to support PSS design. You can name those different methods. Some of them are shown in this slide. But think about the understanding and developing the support, the relation between the two. Without a proper understanding of the, without the proper knowledge of the understanding of PSS design, it's very ineffective to develop support, right? Because you might develop something that is not effective for PSS design. So that's why it's very important to develop more knowledge on PSS designing itself. So this is what I explained, and I want to highlight here one word in the definition. So designed, right? So this definition tells you the importance of designing, in PSS. So precisely speaking, PSS without proper design shouldn't be called a PSS, right? So because the definition includes designed and combined, right? So design in PSS is such an important process. I usually show these 4 questions, 4 important aspects when it comes to PSS design. Design what, and design for what, and design when, and design how, right? So think about these 4 questions for some seconds, reflecting upon what you studied in the last 2 lectures and also the tutorial. Do you have some ideas in mind for some of the 4 questions? In the next slide, you will see sort of my suggestion. So the first question, design what? So what is the design object? In traditional product design, that's a physical product, right? A desk, a computer, a car. But in the case of PSS design, that is a system that consists of products and services and supported by a system, right? So that difference is significant. You will learn in the rest of the week. And design for what? In product design, usually we talk about functions built upon requirements and also needs and wants from customers and other stakeholders. But suggested here is value, which I will elaborate on in the coming slides. So it's on a different level than a function. Okay, so you will hear that later, very soon. The third question about when. In the first one, and both probably first and second lectures, we talked about the importance of the early stage of design. That applies here also. That's why understanding of PSS design in terms of research is recommended to focus on its early stage. Okay? And also that applies to practice too, because without good quality of design in the early phase, the rest of the phases of design is probably not good. Yeah? And design how? This is where methods and supports play a central role. And because of the different nature of PSS design compared with product design, there is a need to adapt design methods applied to PSS design compared with those to physical product design. Yep. So far, is it clear? Okay, good. Now, one question to everyone. Do you know about this? Design fixation. Have you heard of this? Oh yes, good, good. Good start. Okay, then I want to start from the start, but maybe some of you didn't know this. It's a phenomenon that exists in designing process. It's defined as blind adherence of a designer to a set of concepts and thereby limiting the output of the conceptual design process. It was found by Janssen Smith, 91, and they did an experiment of design by giving a task to group of designers. So the control group was given only a task, okay, to design something. And then the experimental group was given the same task plus one solution for the task. And the solution given is described in this picture here. So the task was to design a device to hold a bicycle on top of a car, right? And then this is a solution for that design task. And then this solution was shown at the beginning of the design only for the experiment group. And they analyzed the outcomes from the two groups, and they found a significant difference between the two groups, and showing that the outcomes from the experiment group came up with solutions that are similar to the solution that was shown at the beginning of design. Meaning that if a designer is given an existing solution at the beginning of design, then they tend to search solutions close to that, compared with designers that were not shown the solution. Okay, this is quite intuitive, right? So you will probably understand this with your experience too, or so. But one point to make here is this phenomena is considered applicable to organizations as well, meaning that the experiment executed by Janssen Smith were individual designers, but if we think about organizations, company A, B, and C, then it is considered applicable. If a company A already has a solution at the beginning, then they tend to search solutions close to that. So it's a fix. They are fixated to that solution, right? And so this is a sort of visualization we described described the phenomena related to design fixation, but also we identified sort of a design limitation that is different from design fixation. Design limitation is something that designers cannot achieve, right? There are different reasons for design limitations. By law, by physics, there are many different types of reasons. But designers are given a certain area by this limitation. And based on our observation of different industrial practice of PSS design, we found many cases that fall into design limitation on the left-hand side and design fixation in the middle. So here, as I said in the first and second lectures, PSS design typically is expected to address different domains. One, for example, obvious product area, another service area, and probably some more. And they need to designers need to address those multiple areas in an integrated manner. That is what PSS designers expected to do. But in reality, for example, some laws, regulations hinder designers from coming up with a good solution. Okay, so let's say this is an analogy. Designers are expected to lift the object colored pink towards upward. That's a sort of a metaphor of a given design task. And if you look at the bottom left, then designers are sometimes hindered by certain areas such as laws and regulations, as I said. That is sort of rational because it's not possible for designers to do. But in the middle, this is a problematic situation referring to design fixation, right? So there are certain areas, typically service areas. For traditional product manufacturers, they are excellent in product design. This is typical, right? But they are not so at least experienced with service design. And then in that case, they tend to be fixated to a solution focused on products. And thereby, they don't sort of exploit the design parameters in the service area. So this is what we often observed, and we want them to avoid that, right? So this is where design methods and design support comes into play. And we want to realize this situation on the right-hand side so that designers can fulfill the job by properly addressing relevant areas. Any question for this? No, clear? Okay. So then, coming to the second question regarding design. Design for what? So we suggest value as an overarching concept to guide design different, let's say, pillars, if we refer to the previous slide. Because PSS design aims to design one system consisting of products and services and others. So if you see like a physical product on the left-hand side and service human activities on the right-hand side. And we see these as one system. And if a designer is given a task to design such a system, they need a sort of a concept that can be related to the different areas such as product design area and the service design area. Because typically, if you look at the left-hand side, product designers, in this case, automobile designers, they are given a task, for example, to realize the set maximum speed of a car and also to realize a certain fuel efficiency. So these parameters are attributed to a physical car. But on the other hand, when it comes to service designers, they target completely different parameters. For example, mean time between failures. It's a length in time, service time, time needed to take to execute a certain service, also in time. So these are the parameters that service designers address and also aim to realize. No? And without such an overarching parameter, the system design can't be executed because there is no way to sort of trade off. There's no way to optimize the whole system. So therefore, such a parameter that is above the level that is addressed either by product design or service design is necessary. Okay? So this is an important part related to the second question of PSS design. And the unit could be sort of availability, risk in money, that can be in different dimensions. This will be discussed in the next lecture also. Another thing regarding the complexity of PSS design, there are different levels, each of which has a sort of design space. What we discussed in up to the previous slide is, let's say, designers are given a certain space. In this slide, we use 2 dimensions for simplicity. Let's say designers are given parameter x and parameter y, right? And then by that, we can define a space, meaning design space after the design limitation is this, for example. No? So designers can find a solution within that area. And then within that area, we often observe the area designers tend to search in. That's the sort of design space after design fixation. But as I said before, we recommend designers to go beyond the design fixation space, right? So what I'm trying to show in this slide is oftentimes there are different levels, and let's say there is another level which influences the decision making or the design spaces that the designers are working on. An example is designers are asked to design a specific PSS offering, okay? But a business model where the PSS will be working on is decided by, for example, the company board. And the designers in question don't have a power to change the decision taken on a higher level. So this is quite frequently happening, and we need to have this in mind. Okay. So this slide was shown yesterday too, in the second lecture too, but I would like you to go through the implication on the right-hand side of this table. If each element in the third column makes sense to you. For example, apply systems thinking. No, it's quite obvious from the lecture today until now. Integrate product service views, analyze behavior as a system, consider uncertainty, which I will be talking about in another upcoming lecture. Consider business model, analyze customers, include value proposition, consider system performance, consider service personnel, analyze actors' roles, analyze scenarios, and apply co-creation process. So these are important aspects as an implication for PSS design. Any question for the implications? Do these make sense to you? Good, good, okay. And when it comes to research of PSS design, there have been, I would say, so much research that have been performed in PSS design research, and challenges related to PSS design are actually not only decision making, but also the exact value co-creation process. So design challenges about decision making have been addressed so far in my lecture today, but please bear in mind that there are other types of challenges that occur, especially value is co-created with customers. For example, overcome IPR and legal issues and information flows between actors and coordinate different actors and also supply networks, value chain, etc. Right? Okay. So I would like to, in the coming slides, I would like to share with you findings of our own research that have looked into, and also we have discovered the characteristics of PSS designing process. So the research question that we set out was, is designing for circular economy, CE, designing of PSS for circular economy different from product designing? And if so, how? And we used a method called protocol analysis, and we ran over 20 sessions. And each session, in each session, we asked a pair of designers coming from industry. So they are experienced designers in the manufacturing industry, right? So they are professional designers mainly in the product design business, okay? And then we gave a task and we asked them to think aloud, and then we transcribed all the utterances, and then we applied a certain set of codes, and we made analysis. Okay? So the output from each session looks like this. So the transcribed utterances, and who spoke that, and so on and so on. So each session typically resulted in 1,000 utterances. So it's very long, and it's quite time-consuming to analyze each session, because we need to apply some codes, etc. So we made a comparison between 3 cohorts. The cohort black received a task of designing for a circular economy, design of PSS for circular economy without any support. Cohort orange received a different task. The task was product design. Okay? So the black and orange differs in terms of the task given. Okay? So first, I will explain the results of the comparison between the cohort black and cohort orange. Before explaining the results, some sort of background knowledge about design theories. So we usually say that design space is actually consisting of a problem space and a solution space. In the problem space, designers typically discuss what are the requirements from customers and other stakeholders, and what the design object is for, i.e. the purpose, and also the expectation for the object to behave. While in the solution space, they are expected to, for example, document what the design object is, and also what the objects do, and the sort of documentation and the sketch, and also the different numbers for different parameters, and so on. And applying this idea consisting of 2 different design spaces to all the utterances from each session, we can see that, okay, designers are now in the problem space, and then thereafter, oh, now designers are in the solution space. And then we can easily count the numbers of utterances that belong to the problem space, and also those belonging to the solution space. And then thereby we can calculate the ratio of session, right? Here we see the results. So the cohort black, just to remind you, received the task of designing a PSS for circular economy. And the cohort orange received a typical product design task. We compared the two cohorts in terms of the problem solution index, meaning that if you see the bar higher, then designers spent more efforts in the problem space. So as you see, the task designing of PSS for a circular economy required significantly more effort in the problem space compared with a typical product design task, right? This is an observation, so we didn't give any method or support. Okay, so we just observed. We gave tasks to different groups and we observed. So clearly you see a difference. Huh? So meaning that the message is PSS design requires more effort in the problem space. And we looked also into what designers discussed in the PSS design task and the effort spent for different elements such as product, service, interaction of products and services, and a system. Looked like the pie chart on the left-hand side. So roughly 2/3 of the designer's efforts were spent into the product elements. So now please recall who were the designers that executed this task. The practitioners in the manufacturing industry, okay? Not in service sector, not in the PSS companies. So this is, I think, very interesting observation. And what we think the results mean is like this. My former PhD at Bohemia drew this picture in his PhD thesis. So the person in the picture is a designer, and he or she has a lot of knowledge in the backpack, and now the person is asked to enter a new territory where a new design task is given. And some of the knowledge in the backpack is useful, but it's not certain that all the knowledge is useful in the new territory or not. No? So this is what our sort of interpretation of the results. And then here comes the comparison between the cohort black and cohort blue. Cohort blue received the same task as black, designing PSS for circular economy, but with a certain design support. The design support that we gave to the cohort blue is procedure consisting of 10 steps with iterations. I will explain this more in the upcoming lecture. But here, you just need to understand a certain support, design support was provided to the cohort blue. Now, the results look like this. And here, just note that the number of sessions is not enough to make statistical analysis. So this result is a preliminary one. But still, you see a difference when the session is analyzed from the perspective of system level. So we analyzed each utterance in the session, whether the utterance is about a whole system or discrete element or in between the interaction among the levels. And when the support was given, designers spent significantly more effort in the system level, right? This is what I explained in some slides earlier, that PSS design is expected to apply systems thinking, right? And this result shows that by giving that specific design support, designers indeed spent more efforts in the system level. So this is what sort of PSS design is expected to do, right? Okay. Questions so far? Good? Okay. Then, so somehow I want to summarize what PSS design means in a sort of more accessible form. Although I have shown different slides, the characteristics of PSS design, but I included the letter I, for the 7 characteristics or principles for PSS design. I think these make sense based on what I explained to you so far. The first one on the left-hand side, integrative. No? Product services must be integrated in a certain way. And also information-driven. I will be talking more about the information aspect in relation to digitalization, etc. later in the week. Intelligent, I mean, building upon the previous item. And the next one on the right-hand side, interactive. This relates to the inseparability between the provider and user that we talked about in lecture 2. And inclusive, including new actors in the system, which I will be talking about later. And the next one, indefinite, it's about uncertainty. Huh? We talked about that in lecture 2, and also innovative. So my hope is that take these 7 let's say principles for PSS design and try to remember what is the theory behind these 7 items, right? Okay, so I want to take any question that you may have, and also some discussion points. You have one? Yes, please.
So in slide 17, you said about protocol analysis. So can you just explain a little bit more about what it is?
Yeah, so typically it's also called think aloud method. A person as a subject is invited to an experiment, or person or persons. And typically in the context of design research, a certain task is given to them. And they do the job, they aim to solve that design task, but they need to speak out in all the time when they are observed. And then the utterances, what they say out loud, are transcribed in documents, and then the documents are analyzed with a certain framework of codes. So far, is it clear? Yeah. So, and then additionally, typically different sort of coding systems are applied to a given transcript. And then So in this case, we applied quite simple one. We looked at each utterance in a session, and then we applied, okay, this belongs to the problem space or the solution space. And then we made a calculation of the portion of a session. So, and then to reach the pie chart on the slide, we applied design issues, product, service, interaction, and so on. There are others, coding schemes also, and we also applied some of them. Depending on the purpose of the analysis, we choose the coding scheme, and then we apply that, and then we get the quantitative results. Is it clear? Okay, good. Any other question? Yes?
Sir, in the open
Yep.
system,
Yep.
How do we analyze the uncertainty, like consider uncertainty?
Yeah, good question. Top. Yeah, here. Consider uncertainty. At least one of the lectures upcoming will be talking about uncertainty. And so one, yeah, I mean, we can discuss more after that particular lecture. But what I could say is, as I said in the previous lecture, uncertainty is unavoidable. No? Especially in the case of PSS, there are different types of uncertainty compared with product design. So take those new types of uncertainty as an opportunity. So this is a sort of overall high-level message. But one thing is quantify the uncertainty of different elements in the PSS, and if some of the uncertainties are perceived as risks, then implement mitigative actions. No? So that is one thing that can be done. There are some research with that purpose also. Certainty, yes, yeah. For now, I would say that, and we can discuss more after the particular lecture. More question related to this uncertainty.
Sir, is there like a certain pattern in different sectors, like these kind of?
When the contract is longer, then this becomes more significant. Because the longer time means things can be more uncertain. So that's a difference that we can see in between different sectors. Yeah. Yes, please.
So with the uncertainty related, like in yesterday's lecture, we talked about how it can be either considered as a risk or an opportunity.
Yep. Yeah.
So
Yes.
this
This is. Yes. Yeah. So take the uncertainty as an opportunity as well. That's also possible. No? Yes.
Slide 17, what is the difference between designing and product design? There's two different methodologies you used in slide 17.
17. You mean the task?
Yeah.
Okay. So the task given to the above, black and blue, was to design a system consisting of office-used coffee machine plus the services for that machine. So that was the task given for the PSS design. And the task given to the cohort orange was to design a physical device to block the sunshine on the window of a room. So that was the task. So the tasks are different in terms of the object, either physical product alone or a system including services.
How long did it take to do the entire experiment?
Yeah, to do the transcription or to do the experiment.
The experiment.
Yeah, as I said, a typical session consists of 1,000 utterances. It's typically about 1 hour session. So meaning that first you need to gather subjects, which are people, and then one needs to record the session, and then transcription takes quite a long time, as you can imagine. I mean, maybe you can get help from automatic transcription nowadays, but in order to be precise, I think you need to check word by word. No? And also, the coding step takes probably longer time, not probably, longer time. Because the coding we did is first we used 2 different persons to do the same task, and another person intervenes when the results from the 2 coders are different each other. Huh? So there are 3 persons involved in the coding. Therefore, it's quite resource-intensive research process. Yes, please.
So you talked about the design fixation part.
Mm.
So in the design process, we also tend to do this competitive analysis, like what our competitors are doing. So in this regard, like introducing like doing competitive analysis, at what stage do you think is viable? Like the final outcome, will it affect the final outcome if we introduce the competitive analysis at a very early stage, or what do you think should be the ideal?
I see. So you're talking about competitive analysis? Huh?
Yes.
If I share your understanding of that competitive analysis, I think that is meant to be used rather in an early stage. Huh? Therefore, I would say that if that is used in very early stage, then I think you are more likely to avoid design fixation. And I will explain design processes from, for example, PAL and bytes and what we developed in one of the upcoming lectures. And I think it is common that different design theories suggest such an analysis process at the beginning. Typically, who are involved actors, what are the needs and wants, and what are the expectations, etc., so that designers understand the context of different kinds. For example, the context the company is in, and also the customer is in, and other industrial trends and so on. So that, I think, fits to such an early stage.
Thank you.
More question? If not,
Yeah, so you break for tea, then
We'll have a tea break for 15 minutes and then we'll resume with Sakao sir's lecture, okay? The tea is ready, by the way.
Okay, welcome back. So let's discuss the digitalization aspect. So the expected learning outcomes of this upcoming lecture is that you should be able to describe digitalization elements relevant for PSS design. Number two, explain the benefits of digitalization, using digitalization elements for PSS. And then thirdly, describe challenges, opportunities, and barriers for digitalizing PSS. In this lecture, I will go through some useful pieces of information first, and then thereafter I will introduce some of the research projects that we have carried out in Sweden, and then I conclude with the challenges, opportunities, and barriers for PSS. So I showed this slide earlier, but I didn't explain the aspects about digitalization at that point. So now I'm talking about that particular aspect. So we do recognize the digitalization is one important sort of aspect for why PSS are demanded and expected. So that's highlighted here. And then because of that, we see different opportunities for PSS design. For example, through digitalization techniques, it's possible to better understand user needs and also risks and values, right? We can sort of collect data, if possible, from user behavior and so on. No? And then we can obtain, use, and manage product-related data and information. Typically, industry talks about product lifecycle management software packages, and that kind of business relates to this PSS design opportunity. Huh? And then, by having larger sets or broader sets of data and information, it's likely to be able to apply more holistic systems thinking and also systems design. In the previous lecture, we talked about the aspect of systems design in PSS design. So meaning that characteristic of PSS design can be supported by using proper digitalization techniques. No? So, upcoming few slides will show you some sort of useful information. And when you apply the learnings from the lectures and tutorials for your own work, let's say your own example in this week, I think the coming slides will be very useful for that work that you are conducting. And of course, you should be able to get access to the upcoming tables like this. So the first table explains to you different types of data that are relevant for PSS design. The first one is product specification data, meaning that you address a product and data, various data can be attributed to the product, features and so on. And secondly, usage data, meaning the data about how the product is used, and later then usage result data. Usually, when after product is used, some results are obtained. No? Service configuration data. Obviously, in the PSS context, service is part of the offering, and how the service agreement is made and so on is also a very relevant information. maintenance data relates to the repair, maintenance, and so on of the product in question. Okay? Any question? I think they're very straightforward. No? And then the continue to the data types. Another type is about infrastructural data. It's about the systems that support the product and services in question. Whether sort of environmental data, locality data, and human attributes, human state data, meaning the product users, the data about the users. Okay, so these data types are relevant particularly for PSS design, because I'm referring to this table taken from a PSS relevant paper. So now data is useful, obviously, but to be precisely put, it's potentially useful because data must be sort of used to extract useful information. And the information typically is used in the engineering management engineering processes and also management processes. In the previous lecture, we discussed the design process. So that is located in the second layer of the pyramid here. So now here, interesting thing is when it comes to PSS design, it mainly concerns the engineering and management processes, as well as how the value can be created through the such processes. So these two first layers of the pyramid are the sort of target of PSS design. Data is in another layer, in the bottom layer of this pyramid, and typically, academically speaking, if I may, computer science is the discipline that handles well the data and the information. So here now we see again the opportunity of using two different disciplines to help companies in trying to improve the PSS design. Huh? So now, yes, and also AI, especially with generative AI, provides unique opportunities for doing PSS design in a different way than what could be possible before. So now, regarding the technologies, meaning how to use and how to address and use the data that I explained earlier, this table is also taken from a PSS paper, and it's a bit busy table, but simply speaking, it relates to how to connect different objects in terms of information, data and information as well. That's the first category. And then the second category is how to store the data, where to store the data, and so on. The last one is, okay, regarding analysis, how to analyze such data collected and stored. So in that way, I think it's quite straightforward to understand what are the essential technologies needed for PSS and PSS design. And I think if you look at the right-hand side, it's quite straightforward. What are the enablers? I mean, obviously, you need sensors, actuated connectivity devices for the IoT. It's obvious, and so on. Right? So this, I think, sort of basic categorization is also, I think, useful for you to conduct the application of different learning outcomes to your example in this week. So now, putting us in the PSS context, it is important to have this perspective, life cycle perspective, from the product point of view, right? The product life cycle typically consists of these different phases: part production, manufacturing meaning assembly of different parts and assemblies, and transport and use together with service and maintenance, and after use treatment and management. Typically speaking, traditional product-focused manufacturer focuses on this area. They get components supplied by their suppliers, and then they assemble those, and they ship the finalized product to a customer. As I said in the first lecture, moving the box, no? And then thereafter, the company's responsibility is basically over. No? So what this setting incentivizes manufacturing companies is that optimize this system. Huh? And obviously those manufacturers have been providing other services taking place in outside the system, for example, repair and take back and so on. But simply put, they are not the core activities if you follow this system. But now, there are opportunities that have emerged, for example, reuse and using the products again and again, and also remanufacturing and also recycling. Regarding the digitalization, a lot of data has been collected from each of these phases. Huh? And here, what I want to say to you is there is a big opportunity of applying this broad perspective, which allows a company to see the connection, or at least to analyze the correlations between different data sets. Each of the sets comes from the different phase. Huh? To see the connection. For example, if a company finds a specific pattern of user behavior from this phase, that information belongs to here, but that information can be analyzed in correlation with the data sets coming from design, which doesn't exist here, but the manufacturing and also part production. Okay? For example, if another example is if unexpected malfunction of a specific component happens in the use phase, that component, particular component, might have been inappropriately produced in manufacturing. If a company has stored such data of each production batches, then that information can be effectively used to help technicians in the service phase. So these types of activities can be done only by this broad perspective and also analysis of data and the information coming from different phases. So this is, I think, very relevant in the context of PSS design when it comes to digitalization. It's not really about the technological aspects and also physical feasibility, but to see this opportunity with a broad perspective. Huh? So if I should have implemented the animation on this slide, but you should have seen the major part of the ice. You know what I want to tell you. So this is the major part of the iceberg can be seen if you have a broader perspective, right? Okay, then another big table is about digital capabilities, especially in the PSS context. you can maybe focus on the second column, middle column. These are the questions that can be answered if you have a proper digitalization system, and also if you have a PSS design in mind. First, who is using the product at a specific time, etc. So regarding user, and which specific product instance and product model. And the next one is, where is the product located? It's about geographical location. The next one is about time. What's the point in time? Huh? And then the last one in this table is the use intensity. For example, how much is, for example, a car used? How many times per unit of time is the product used, right? What's the condition? How is the product working? Why is the product used? Regarding the purpose, I think you probably studied and learned different cases of industry regarding the digitalization. And I'm not sure about your exact experience, but thinking about my experience from co-working with different companies, it's quite surprising to see that these questions can't be really answered because of the lack of digitalization system or the lack of motivation. We don't have to know this. We don't have to answer this, right? So it's quite surprising to visit company and ask the status of regarding these aspects. And for example, it was quite surprising when we were working with, let's say, a vehicle manufacturer, and then there was no specific system that records the purpose of the vehicle per customer. So, but depending on the purpose of the vehicle, the deterioration of the vehicle quality differs significantly, of course. No? In that case, a vehicle is used in some cases in, let's say, on the seaside, let's say in a sort of, for example, fish market and so on. And the other, in other cases, it's more sort of a restricted environment, in-house environment. So these two different conditions, quite significant. No? So to get the information and also use that information is quite powerful. Huh? Prediction and also adaptive related to remote control and optimization prescriptions, and also the autonomy, how the product can act by itself and so on. So now related to a circular economy, because I need to explain this for the coming slides. In this week, at least from my side, I would recommend to refer to this definition for a circular economy. It's about technical products. But more in general, a circular economy has another aspect, which is biological cycles, like foods and forestry, etc. But those things are not in this course, from my point of view, and therefore, in this lecture, at least, a circular economy is about technical product, and it's about restoration of the products and products and components through maintenance, reuse, refurbish, remanufacturing, beside material recycling. So this is what I will be talking about circular economy. Right? And the upcoming 2 slides explain how digitalization can contribute to realize circular offerings, circular economy, motivated business offerings. In many cases, they are relevant to product service system. So you see on the left-hand side business goals, for example, connecting different actors, and the second one is about understanding product and customer behavior, etc., etc. The third one is product reliability, lifetime extension, and so on. So this table shown on this slide and also on the next slide explains to you how different activities based on digitalization can be really help each organization in terms of the company's goals. So I think this table, also in the next slide, is again useful when you apply the learning outcomes in your example. Okay? So, and looking into practicality, typically each company is limited in its resource, and of course the goal must be set at a certain level, and this is taken from publication by others saying that there are different levels when services, support services are provided. And typically, company gradually implements such supports, and then in this case, company can start level 1 and gradually climb up the ladder. These are, I think, these levels are quite straightforward too. For example, the basic level is about creating digital manuals and also using smart devices and so on. Then the next level is supporting the customers when it comes to diagnosis of the product and so on. So this sort of piece of information is also, I think, useful when you apply to your case. Is it clear so far? Okay, good. So from now, I want to share with you some of the research and innovation projects that our team has been working on. This slide shows sort of architecture for the software aimed to support companies to deal with data related to the product life cycle. And in this particular research and innovation project, we planned to develop such software building upon an existing commercial software for the PLM. Typically, if you look into industry, commercial software vendors have their own software packages. They claim that they are useful for PLM, product lifecycle management. But I would say typically there are development opportunities for the PLM part, especially compared with what I explained so far in this lecture. So we saw a development opportunity here as well. We worked with a specific vendor, and we saw an opportunity, especially the additional input and output with designer, such as lifecycle cost data, revenue data, and also as an input from designers, like, for example, maintenance data, maintenance planning data, and take-back plan, and pricing model, and so on. Those are what I have been explaining so far in my lectures related to PSS, which are important. No? So this is just one example of us having seen the development opportunity when it comes to software for really supporting companies to exploit the PSS design opportunities. And I'm sure that if you look into software industry landscape, I'm sure that you will see the development opportunities as well. This is a very good business opportunity, by the way. Okay. Next one. One of the innovation projects that we have been running is about how to use artificial intelligence in the context of lifecycle engineering. You can recall the pyramid slide, which I showed in this lecture. Typically, AI or computer science looks into the quality and performance of the algorithms, how fast a given algorithm can solve a given task, and so on. That's their typical problem. But when it comes to PSS, we want to improve the lifecycle performance of the product and other things. And usually we see a gap between the two disciplines. And then that gap we wanted to fill in this research project. And then this picture shows our vision for how to use artificial intelligence in a better way for a better lifecycle engineering. So at the bottom of this picture, you see different activities or different lifecycle phases. For example, product design, service design, product assembly, production design. So all of these are lifecycle phases. And I think you remember one of my earlier slides showing different lifecycle phases. So I think you remember how they are sort of connected to each other. So typically, traditional lifecycle engineering thinking builds upon a sort of serial series of different lifecycle phases. Design, and then manufacturing, and then use, and then service, blah, blah, blah. But we think there is a big opportunity, not by seeing such a sequence, but seeing a collection of different activities. Because, for example, when maintenance and repair takes place, data can be collected and then that data can be immediately used to service design right away. So instead of waiting for the analysis and capturing useful information and applying that information to a next product lifecycle generation, but we see an opportunity to use the data and the information in a much more fast and also effective way, so that these different lifecycle phases will be sort of much more organically connected with each other, helping different phases with each other. So that's how we see sort of future lifecycle engineering could be. And interacting with those lifecycle phases is intelligence that consists of artificial intelligence as well as human intelligence. Because obviously we believe that human beings must be involved in important decision making. So therefore we see, we put business intelligence at the top, right? And if comparing the new way of doing lifecycle engineering compared with the traditional lifecycle engineering, we can say that, as I said before, the time for implementing a certain change is much faster, or to be precisely, that will be much faster if a company implements this vision in reality. And also, another highlight is the accuracy of the changes made in such a digitalized environment will be much higher than right now, because of the sensors and also analytics of the data coming from those sensors. The analysis can be made for individual product instances. So that's why we see potential of the much more increased accuracy in making any change. Okay. And we looked into different research works related to application of AI technologies to different life cycle phases. We found that there are quite a few research works that have applied different AI technologies or data analytics methodologies applied to different phases. So there are different research works ongoing, but in reality, meaning that when it comes to the application of these AI into practice, we see a big gap. And I think this is an opportunity for research and also practice. So, talking about the different life cycle phases, where product and components and parts are circulated from the middle of use or end of life to the upstream of the value chain. But we know that for those physical flows, especially for the reverse flows to happen, we need to have information flows as well. For example, let's say if a service technician faces a product in the use phase, the technician needs to know the history of the specific product, for how long the product was used and how the product was used, in order to make judgment for the appropriate second life of that specific product, right? If the product is used like for a very long time, then that may be not useful for the reuse, for example. So that means in order to make this anticipated physical flows, we need to have associated information flows as well. But looking into the literature, we found a number of research works that were applied to specific life cycle phases, but this life cycle perspective is typically not used. So meaning that each research work has looked into either, let's say, production data to improve production, use phase data, improve use phase, and so on. But this sort of the application of information across different life cycle phases is very rare, even research. So that's why we say that we make this kind of statement that very little work has been done so far, and this is a big research opportunity. For you to have a better understanding, one of the examples that I mentioned is like this. So they looked into the data set coming from the car sharing service in Germany. They looked into the 35,000 drives by about 2,000 users, and it's a potentially very good data source, no? And then they analyzed the data set in order to improve the energy efficiency and also the personalization potential depending on the users. And then they used machine learning, and the paper shows the credible results, meaning that the benefit is there, exists, no? But the point I am making based on that publication is that that information and sort of learning should be also used in product design, so that the product design is adjusted according to the data coming from the use phase. So this is the example that I wanted to tell you. So another case from our project is that we access to the data of maintenance reports. So we work with a production facility. They have a number of production machines, and there are, let's say, several dozens of maintenance engineers dedicated to maintenance activity. And from time to time, problems occur from different machines in the production line. And for each problem, obviously they fix the problem, and the problem and also the reaction that solved the problem is recorded in a certain computer system. And record contains free text description of the problem and the problem solving. And then we analyzed that free text. And then we managed to produce such knowledge graphs that looks like this, based on the free text plus the ontology given to the system. The ontology means something like this. So basic concepts used in this maintenance work and so on that were developed together with the AI experts and the practitioners in this factory. So this is, I think, very useful. So nowadays, text data is, well, ubiquitous. You name it. No? Consumer reports and sentiment reports and so on. That can be used to derive more organized way of representing data, like this, for example. But I think this data has a big potential to be used in, for example, design of the machine, in this case, and design of different offerings when it comes to sort of consumer reports rumors and so on that can be used in design stage 2. So I think this example shows such potential, and I think you can easily point out, there is a potential in different manufacturing companies and other types of companies. And I think this is the last one from our own research and innovation project. When it comes to application, there are always challenges related to the organizational setting, different contexts, and so on. Then we looked into implementing condition-based maintenance as a product service system element. And then we asked 3 different companies, and we collected different challenges and also existing solutions. And the challenges are widespread in the organization and the context, and the challenges might be related to information as such, people, technology, and the system. And the message I'm conveying here is when you think of applying a certain digitalization technology, then there will be challenges. And the challenges are not only about the technologies as such, but also the context and who will be using the technologies and who will receiving the results of the application of the technologies, etc. So please have this kind of thing in mind when you think of the application into your example. And the last, I think, 2 slides show the such opportunities and also barriers for small and medium-sized companies when they aim to implement PSS design with digitalization in mind. If you look at the left-hand side, I think these are quite understandable, especially on the context of small or medium-sized companies. Some are about digital strategy, some are about internal and operational organization related issue. There are opportunities and barriers both. And I'm quite sure that after graduation you will be working sometimes, at least, with small or medium-sized companies. And you need to think about these aspects. The last slide. The theme could be the ecosystem, the whole ecosystem, and also the capabilities of the people involved. I think this is the last slide. So one message I want to once again convey to you is typically when it comes to use of digitalization, so this is the sort of motivation. So we see an opportunity to improve the efficiency. We can do this faster, from 1 hour to 1 minute, or even 1 second. So this is a typical motivation. But when you apply this thinking to each single element of the process and system that you are in, typically you have a risk of getting trapped into sort of, let's say, efficiency trap, meaning that even if you realize this improvement of efficiency of each single step, you may not reach the better system or better improvement if you look at the system as a whole. So I think PSS design gives you such a sort of thinking and also perspective to keep the broader one and trying to improve the whole system. I think with that, I want to open the floor to take any question that you may have. Yes, please. Yeah, yeah. Microphone.
What is meant by digitalization specifically in this context? Because we see many things getting digitalized, so processes, products, what exactly?
I see. In this context, so I didn't use the term digitization, which means basically changing the for example, digitizing data as such. So that is a fundamental one to realize digitalization, probably, as you know. And digitalization here involves the implementation of such digitization into a given context that involves different organizations, like work procedures, workflows, and so on, so that certain benefits can be obtained. So that's how I would say for digitalization. So in the context of PSS, PSS can be envisioned in different ways, and some of them can't be realized without effective digitalization. For example, providing services depending on the user behavior. That can be envisioned easily, but without getting the data of customer A and analyzing that data, that sort of adaptive service can be provided. No? So that is, I think, an easy to understand example. Yeah. So other questions? Yep.
So you spoke about organizational setting, right?
Yeah.
So to understand that, how did you understand that? Was it through just research, or did you go for what is already in practice? How did you understand the organizational setting of an organization?
Were you referring to the second half of this?
Yeah, second half.
Okay.
You were talking about the organizational setting, right? So how did you understand that? Was it just through research or through data from a particular organization?
Yeah. The organizational setting includes different aspects, right? And we typically communicate closely with the practitioners involved, meaning, for example, in the case of the production machine failure data analysis, we first aimed to understand existing systems and how these systems are used and who are involved. Those kinds of information pieces are collected and also taken by the researchers. No? So through the such interaction, we aim to reach a better understanding of the organization. No? Yeah. Hmm? Yep.
So, sir, earlier also we talked about that information that we can collect in different stages.
Yep.
That can be used and implemented in other places to overall benefit. But what if the cost of that implementation is much higher? Because for SMEs, it is like the probability of implementing that infrastructure will be much higher. So how do we analyze things that okay, implementing this thing will benefit us a long term, so maybe we should have the burden to invest in that infrastructure?
Yeah, very good question, I would say. And my response would be, so coming back to this thing, there are a number of opportunities that could be taken, and obviously each opportunity provides different return on investment, so to speak. And then obviously SME and the like is limited in its resource, and therefore they need to make a rational choice. And I think PSS design offers a unique opportunity by providing a wider selection of such opportunities, meaning that not starting from what is possible, but starting from what is desired, what is expected, what is wanted from a broader system perspective, and thereby making it possible for even an SME to choose a better one among them. So obviously, the resource is limited, and then they want to choose higher return on investment items. But think, have this in mind, no? So that's, I think, the message. Okay. With that, yes.
With that, we'll leave for lunch, but before that, kindly mark your attendance. We'll be meeting at 2, okay?
Okay, so welcome back. We are now going to discuss a toolkit that is called the Tiles IoT toolkit. So this entire discussion is based on the PhD thesis of Dr. Liladhar Ganbhir, who has recently graduated under my supervision from our department. So, so the most of the discussions are primarily based on our work in that particular thesis, right? So, in the thesis basically we have worked in the context of smart home, right. When you talk about smart home, it is a PSS, it is a product service and system. So, we will just quickly see what is the product service and system component in a smart home, and what are the issues that governs the design of a product service system in the context of smart home, and how did we finally arrive to a framework for smart home PSS design, and then how did we develop the tool, right. So, I will also demonstrate you the tool. So, the tool was practiced in our department studio, and we got very good outcome of that particular tool. So, now let us just move ahead with the discussions. Like yesterday when I discussed about different technology adoption models like TAM, TPB, etc., the question started coming in that how do I identify the factors that is going to I need to consider in the TAM or TPB. So, the basic answer was that you need to conduct a consumer behavior study, maybe through a qualitative method or maybe certain quantitative methods, and then you identify what are the attributes those are affecting the consumer behavior, and you need to consider those attributes and variables when you finally try to apply the TAM or TPB for your study. So, here also we have tried to understand that what is the consumer adoption issues in smart home. The questions that this particular PhD thesis tried to answer are, what are the fundamental terminologies in smart home IoT products. So, whenever we talk about the smart home IoT products, right. So, whenever you talk about smart home, basically you are talking about IoT, Internet of Things. So, it can be industrial IoT, it can be the home automation IoT. Here we are only talking about the smart home IoT. And which are the factors affecting the consumer adoption of smart home IoT products. So, how does this idea just came in our mind is that most of the smart home offerings that you see in the market, those are being designed by considering the Western context. But in Indian ecosystem, the our daily life is very different from a household in a Western context. Most of the smart home offerings that you get, those are being designed considering the user behavior in the Western nations or maybe in the developed cities, right. So, now in the Indian multicultural fabric, how do we consider the smart home adoption? Because our day-to-day challenges in home is very different. We have joint families, we have different way of operating, we have different kind of utensils and equipments, and for that matter different objects in our home, which is not similar to an India maybe a Western ecosystem. So, when but there is a huge market for a smart home as a PSS offering. So, there are people in the Indian consumer market who are looking for smart home offerings. So, how do you map these gaps? So, what is the consumer expectations, what kind of problems and the consumer pain points that we have in terms of the leading their day-to-day life, right? And then what are the different offerings that an organization can come up with. So, for that matter, we started doing a consumer behavior study, and we actually tried to understand that what is the motivation or barriers for adoption of smart home in Indian context. So, in yesterday's discussion, we have talked about these models like the theory of resonance action, the theory of planned behavior, the unified theory of acceptance, use of technology, technology acceptance model, norm activation model, value based adoption model, technology readiness index, innovation diffusion theory, perceived risk theory, and cognitive dissonance theory. So, these were the theories that we discussed in the yesterday's class. Now, the question is, given this kind of a situation that we are doing now a study in order to understand the user behavior from the perspective of technology acceptance and technology adoption in the context of smart home in So, in Indian scenario. So, we try to do some trial and test of different these methods. We found that the TAM was actually evolving as a very powerful tool in this particular context. So, what is learning point for you is that you have these tools in your basket. So, depending on the kind of situation that you are encountering with, you need to pick up tools, do some trial and error, then you finally decide on a specific tools and methods, right. So, in our case, we actually decided on the TAM as a model. Now, how did we analyze the characteristics of smart home production surfaces? We took Kano model as a reference. So, the Kano model, as you know, it's a method prescribed by Noreki Kano. Again, it's a Japanese model. So, which basically talks about the classification of the user requirements in 6 different categories like attractive, one dimensional, must be, reverse, questionable, right. So, I am not going to discuss the Kano model in Kano model here. Just for your information, we use Kano model as a framework to analyze user behavior, so that we could identify the attractive features of smart home, right. So, smart home as an offering, right. So, we tried to build this kind of stories, and we started developing this kind of scenarios in the user behavior study. For example, television giving updates of surrounding and who is on door apart from their main purpose, right. So, so if you directly ask these questions to your consumers, they will not be able to answer, right. So, so learning point from here is that whenever you are doing a user behavior study in this kind of a given situation, you need to give them scenarios, you need to give them stories where the product and service is integrated. You cannot get the insights from the consumer by direct questioning or maybe a stereotype questionnaire, right. So, so you need to be very creative in designing those instruments on the basis of which you are actually going to capture the insights of the user. So, so we are developing those scenarios and those stories, and on the basis of this creative questionnaire, we started collecting data about the user behavior, and then we started identifying, okay, these are the different attributes that those basically affect the user behavior in smart home, right, and that too in Indian context. The other context may be the garage door opens up when it detects the car is coming. So, the garage door automatically opens up. Home door welcomes the owner and alerts when it detects unauthorized entry. So, the limitation of the entire study was that we considered the metropolitan cities in India. So, we did not consider the urban or the semi-urban or for that matter the rural areas, because the proximity of this smart home as an offering for that segment of customer is still very less. So, we actually considered the consumers in living in metropolitan cities or maybe A-class cities, right, and primarily people who are living in apartments, right, rather than living in individual household. So, we have finally arrived to the definition of the smart home PSS, right. So, what is learning point for you here is that how do you define PSS in a given context, right. So, the PSS for the food delivery system, how do you imagine, or how would you like to define PSS in food delivery system, right? Yesterday during the discussion of the topic, you proposed lot many different areas. No? So, you should be able to define that in your context, how do you define PSS? Like one basic challenge given to you was that how do you identify the product part of it, service part of it and system part of it, and then finally how do you define the PSS context in that particular given situation. So, in our context, that is in the smart home, we defined it like the smart home PSS is an IT driven value creation business strategy consisting of various stakeholders as the players and residents, right. So, in this whenever you talk about services system, actually you are dealing with so many different stakeholders, so many different entities. In the morning session also, Tom talked about different stakeholders and right. So, different entities and the systems thinking, because the moment you are talking about PSS, you need to apply systems thinking, right. So, it is not the traditional product design approach is going to help you, right. So, so continuing with the various stakeholders as these players and residents are smart systems as the infrastructure and home, smart and connected products as the media and tools, and their generated e-services as the key values delivered that continuously strive to meet individual customer needs sustainably within the context of a residence, right. So, that this is the way basically we try to define smart home product service system. So, here we are talking about how do we integrate different stakeholders in this particular ecosystem, what are the different gadgets and different objects that you are basically integrating, and what is the technology that you are using, what are different kind of sensors or different connectivity algorithms maybe you are using, and then how you are finally creating a value, right. So, that continuously strive to meet individual customer needs sustainably, right. So, in the tool that we have developed, there we have considered the 17 sustainable development goals, right. So, from so you may pick up any of those 17 sustainable development goals and then you may move ahead, right. So, we actually took that kind of an approach. So, where the sustainability is in concern, if you look into the basic theories of PSS, you will find lot of literature basically talks about the sustainability, the link of sustainability with PSS. In the inaugural session of Tom, he himself argued on that particular aspect. So, so consumer is sustainability within the context of a residence. So, our context is only limited to residence, right. So, from our study, finally we arrived to a conceptual framework of the smart home product service system. So, in this particular framework, you can see this product part separate, okay, maybe I will come here. So, you can see this is the product part, this is the service part, right. So, so in the product part you can see independent, adaptive, reactive, multifunctional, ability to cooperate, proactive, self-descriptive, communication and collaboration. So, this particular SSPSS has been developed based on the basic framework of product service system, right. So, this is an empirical study. So, you already have an established framework for product service system. So, we have just tried to experiment with the existing framework of product service system, and then we have tried to blend it with the specific issues of smart home, right. So, for your project that you are doing as a part of this course, you can follow the this SSPSS framework, right, because it is built on the basic PSS framework only. So, here we have identified that these are the product attributes. Service attributes we have identified that the context awareness, interpretation, personalization, user friendly environment, human like interaction, personality, cooperation and openness. So, these are the service factors that we have identified in the context of smart home, right. So, we have very clearly identified what are the product attributes which is tangible and what is the service attribute which is intangible, right. Then you see when you talk about product, it is basically the your orientation is the product orientation, right. This is use orientation. Use orientation is what? The mix of product and service, right. Result orientation is the service. Finally, as a consumer, you are hardly concerned about what the product is, fine. So, finally, what is the service, right. So, finally, is the consumer satisfaction whether your purpose has been met or not, right. So, that is the result orientation. So, whenever you talk about product, your orientation is the product orientation. Whenever you are between product and service, it is basically the use orientation mixed of the product and service. But when you are talking about pure service, basically you are talking about the result orientation. So, the result orientation. So, whenever you are talking about the product service system, you need to be very clear about these three aspects. Then we talked about the digital capabilities, right. So, in the digital capabilities, we basically talked about three attributes: intelligence, connectivity and analytic. In terms of intelligence, we talked about embedded systems, sensor as actuators, edge computing and fog computing. When you talked about connectivity, we talked about Internet of Things, we talked about wireless, we talked about cloud computing communication. When you talked about analytics, we talked about the big data analytics, digital twin and AI technology, right. So, then these are the basic three focus that you have identified. So, whenever we are going for product service system design, we arrive to the conclusion that we need to focus on these three. One we are calling it service dominant, that is in short we are calling it SD, that your entire focus should be service domination. So, service has to predominate this entire aspect. Like in Tom's lecture also he talked about that, okay, in certain aspects so the domination is more of the product, in certain aspect you find the domination of service is more, right. Here we have taken a position, you need to take a position that in this particular PSS who is dominating, right. So, in this particular case we identified that it has to be more of service domination. And the closed loop design, the SSPSS closed loop design and co-creation rules. So, it has to be so intelligent, so that it can co-create, right. It has to evolve, right. It has to evolve and it should be able to collaborate and co-create, right. So, this was the basic vision that you have talked about. So, service dominant, data driven value creation and closed loop design. So, this is the overall framework of the product service system design that we have visualized for our case. So, our case is the PSS design for smart home, right. I am just repeating, right. So, the basic framework for any PSS would look like this. So, basic structure of, so if you look into the skeleton of the PSS, right, skeleton of the PSS framework, you will find that the product and service, right. You need to identify what are the product attributes, what are the service attributes in terms of where your focus is, right. You need to also identify your capabilities in terms of the mix of the product and service, right, and how to define those capabilities of that particular PSS, right, and what is the vision of your PSS, right. So, what are the basic focus that you would like to have as a visionary offering of your PSS, right. So, this is the skeleton of any PSS framework, and for example, I am showing you the framework that we have developed for smart PSS. This is an outcome of more than 2 years work. So, right, so as far as your project is concerned, you won't be able to. So, it takes lot of time, right. So our expect as because I am showing you a PhD work. So, what is expected is that a company who is into smart home PSS design, right, they can adopt to this framework and their designers can actually work like this. So, this is our proposal. So, this is what we are proposing to the organizations who are into design of PSS for smart home, right. So, this is what we are proposing, right. So at your stage, you won't be able to do that in this particular course, but what is learning for you is that understand the framework, and when you do the exercise, try to get some inspiration from this framework and then try to identify the attribution. Yeah. Please speak a little bit louder. Just a minute.
So the question is, with things moving towards smart, like technology evolving towards our home.
It's on, it's on.
Oh, hello. Okay. Yeah. So how much do you think importance should be given to you know, something private? Like home is a very private thing. So smart homes, people is like very excited about it, but at the same time people are also concerned about their privacy. So in the survey, like what
Yes, yes. So, I'm just repeating her question for the benefit of all. She was asking that, okay, the moment we talk about PSS design, the data privacy is something very important, right? And she was also referring to that, sorry, because you're talking about now PSS and smart home. So, data privacy is something very important, right. So, for any PSS that you talk about, so the moment you are dealing with financial data, health data or personal data, right. So, the data privacy is something very important, right. Primarily the financial data, health data and the personal data, right. So, I am fully with agreement with you that the moment we talk about this kind of PSS, that has to be considered, that has to be definitely considered, because when you talk about the data driven value creation, right. So, the when we are talking about data driven value creation, data security and data privacy, and how do I ensure your data privacy, that is definitely there, that is definitely there, there is no disagreement, right. So, whenever you talk about the data driven value creation, we are talking about the cloud computing, we are talking about the data driven value creation, definitely the data security and data privacy issues will come in, right. Thank you for pointing me that.
So that will again, how you first talked about the smart homes concept being applied in Indian context.
Yes,
I think
yes.
there again the people would find it more advanced themselves.
Yes, obviously, because again the like the barriers and the acceptance, no, like she was pointing out, the moment you talk about in Indian context, again those things will come, right, because the privacy issues will come. Yeah, right. So from our research, we identified 7 different toolkits. Those are being used in industry, right. So, the organizations who are into PSS design, they tend to use this 7 tools, and most of these tools are basically card based tools, right. So, we have actually interviewed lot of professionals who are into PSS design, and we found that they use these different 7 types of card based tools. So, card and dice co-create the IoT design decks, IoT design IoT ideation design kit, no cards, mapping the IoT, and Tiles IoT toolkit. So, we finally decided to take Tiles IoT toolkit as the basic reference toolkit to design the smart home PSS design toolkit, right. So, so this is the basket of toolkits available for you. if you are a PSS designer, you can pick up any of these tools, and these are all ideation toolkit, right? These are all ideation toolkits, and most of them are card based toolkits, right? And then it's a game that the designers they play, and then on the basis of that they come up with different concepts, right? PSS concepts. So we took Tiles IoT toolkit as our reference toolkit to design the tool for smart home PSS design. This is the mapping of different toolkit, right? So we identified these 6 different attributes on the basis of which we analyzed these toolkits, because the moment I say these are 7 different toolkits, all these 7 different toolkits have different pros and cons, right? So in different contexts, different toolkits work better, right? So then, so we just try to identify that from problem solving, from inspiration, from ideas, from technical capabilities, from mitigating implementation problem, or for planning implementation perspective, which toolkit is lying where. So we just tried to do a mapping, and then we found that the Tiles IoT toolkit. So it was basically talking about it was basically in between the problems and the technical capabilities, and then we decided to go ahead with it. The Tiles IoT toolkit. So as a designer, you need to take your conscious decision. So when I talk about different tools and methods, right? So yesterday we have talked about different methods for technology acceptance study and technology adoption. So here I am proposing you 7 different toolkits for PSS design. So which toolkit are you going to pick up? It is you need to take a conscious decision, right? So you need to understand that which particular toolkit is having is more powerful in a specific aspect, right? So depending on the context, you decide the toolkit, and we took a decision to go ahead with the Tiles IoT toolkit. Yeah. No. All these toolkits are for any PSS, any product service system. SS PSS toolkit is our contribution. Smart home PSS toolkit design is the outcome of our PhD, right? But these are all generic toolkits available for any PSS designer. Like the kind of problem that you are encountering with, you can pick up any of these toolkits. I'll explain you the Tiles IoT toolkit. It is a small change in the so our toolkit is an empirical study on the Tiles IoT toolkit, and we have done some modification on the basic Tiles IoT toolkit, right? So you will be able to understand it in the context of smart home, right? Yeah. So these are generic toolkits for any PSS design.
Regarding co-create the IoT, so is it relevant to participatory design?
Participatory design. So when you talk about the co-create the IoT, we are talking about the participatory
and it's
design.
different from, like, how is it different from card and dice, because over there also, like, we are taking feedback.
There also you are taking feedback, but this co-create and IoT is basically linked between the problems and the inspiration, right? So maybe you are not going very deep into technical capabilities. You are more into problems and inspiration, because the moment you talk about the co-design, you may not consider much of the technical capabilities and the technical constraints, right, that way. Now come to smart home PSS innovator toolkit. So this is the toolkit that we have developed, right? So again, it's a card based tool. So this is how the toolkit was being administered, and you can see some of your seniors there, maybe, right? So people who are from our department, so they participated in using this particular toolkit. Okay, so again, it's a brainstorming game. It's a brainstorming game kind of a thing, right? So the basic layout of the toolkit looks like this, right. So, so you get a big sheet and where you have different positions. I'll show you the entire protocol, how do you play it, and you have different cards, right. So, the basic layout looks like this. You have triggers, you have things, you have responses, right. So, here you put the cards, you have some reflection criteria, benefits and barriers, right. You have some missions, right. Okay. So, let me talk about the cards now. So, you may, so I have basically 4 sets of cards. One is the domain cards that you talk about a scenario, you talk about a scenario or a persona, right. So, so in smart home, the scenario you can start with the baby or maybe an elderly who is there in the home, or maybe you start the scenario with the with a homemaker, or maybe both husband and wife are working. So, in different scenarios you start building. So, so scenario and persona, right. So, so in the domain cards, with the help of domain cards, you can develop different scenario because there are already predefined personas. Technology cards, you have things. Things are the physical objects that you encounter in your daily life, right? Like the objects that Don Norman talks about, right? So, design of everything things. So, so what are the different objects that you encounter, right from the toothbrush to the reading lamp that you finally switch off before going to bed, right? So, what are different objects that you encounter? So, those I am calling things. It can be different sensors, those are attached to those objects, right. Services, what are different services that you are getting through those objects. Human actions, what are different human actions that you do with those objects, and what are different feedback you start getting from those objects, right. So, things, sensor, services, human actions and feedback. So, these are all technology cards, provide simple descriptions of technology like things, sensor, data and user interfaces. Mission cards spice up your mix by providing provocative design goals. I give you a design goal, right. So, I give you a design goal. So, the design goal may be the mitigating the risk of an elderly in home, right. So, so you have a design goal, right. So, or maybe empowering the kid to learn himself or herself, right. So, how do you give different design goals? So, so those are your mission cards. As I told you, we also took the inspiration from the 17 sustainable development goals, on the basis of which again we tried to define the mission cards. Then the criteria cards are the cards on the basis of which you evaluate the ideation. Remember, this particular tool you are going to administer with your designers. You have a group of designers and you are going to, you have given them the basic design brief. Okay, this is what my client is looking for, and then you expect your designers to come up with your idea. So, so again in the morning the design fixation was debated, right. So, so why do you use all these tools in order to overcome those design fixation? Otherwise, your designer may have some preconceived idea, right, or he or she has seen some this kind of offering somewhere, and many times his or her entire idea may get biased towards what he or she has seen. So, in order to avoid those, basically you use these tools. So, you very clearly talk about, okay, this is my mission criteria, these are the domain cards, these are the things cards that you have, and you have certain criteria cards, like we have different design screening method, like Stuart Book design screening method, right. So, these criteria cards are screening methods on the basis of which you are going to screen the concept. So, as designer, we all know that you need to have a basket of concepts, and then finally you do a synthesis, and then you arrive to your final solution. Does not mean that the concepts, those are not getting qualified as a part of the solution, you need to throw it out, right. So, it has to be kept in your archive for your future reference, but you need to have certain criteria on the basis of which you are going to do the synthesis and do the sorting of the concepts those are being generated by your design team. So, for that matter, you have this criteria cards help to reflect and coverage towards meaningful ideas, right. So, those are we call the reflection cards, or so in our case we are calling it reflection cards, right. So, those are criteria cards. So, as I showed you the layout of the tool, so it goes like this. So, first you create a scenario, you take a specific scenario in a smart home context perspective. You pick a persona in the scenario, what are the different persona those are going to play a role in that particular story, right. Then you define the missions. So, these are the missions of this particular ideation exercise. Then you pick up things, no? Then you pick up things, right? Then you come to the triggers, right? So, if you pick up these things, if you pick up these objects, what are the triggers of those? What are the triggers of those sensors, or what are the triggers of those objects? Then after the trigger you get the responses, feedback. The first is the pick up the object, right? It will give some trigger and then some feedback, right? So, things, triggers, then responses, right? After responses, then you flesh out your concepts, right. So, if this is the scenario, if these personas are there in this particular scenario, and if these are the objects that they are interacting with, and these are the triggers that they are getting from these objects, and as a result of these triggers, this is the feedback which is coming to the entire system. So, then what is my idea, right? So, then you start developing those storyboards. You might have now imagined that this is going to create lot of stories, right? So, we are actually inspiring the designers to write the story of it, right? So, then then you flesh out the idea. Once you have the idea, then you have the criteria. So, the criteria cards are basically, as I told you, evaluation. So, on the basis of which you are going to evaluate, right. So, it can be the benefits or the barriers, right. So, what are the benefits of this kind of an idea, and what are the barriers of this kind of idea, right. Okay. I will further explain it to you in detail. I have just shown you the protocol, that is the protocol. Now, let me go step by step. Start by selecting a persona and a scenario, right. So, you pick up, so persona and scenario, those will go together hand to hand. You create, okay, this is my scenario and this is my persona, or by maybe these are the two personas and this is the story, this is the scenario that you have agreed to focus on. What specific needs or problems are you trying to solve for the user selected? So, whatever the persona that you have selected, what are their problems that you are trying to solve? What are the problems that you are trying to solve? You can place the chosen scenario and persona cards in the card placeholders at the bottom left of the corner board. Then refine the mission. Challenge yourself to think creatively about the purpose or mission of your idea. Use up 3 missions card to challenge and guide your idea, right. So, you pick up certain mission cards that, okay, this is the basic objective or mission of my entire ideation exercise. What objects are central to your user? What objects are central to your users, and how they can help solving the needs you have identified, right. So, what are the, so if this is the scenario and these are the personas, what are the objects that they are going to interact with? Look through the things cards. So, then you have a set of things card, and we have actually documented all the different things that you are going to, most likely you are going to interact with in a smart home context, right. So, you start picking up those things cards, select a few of them as your starting point and place them on the card placeholder in the things section of the board. You may not pick up all the things card at a time, maybe you pick up 1 or 2 or 3, then you start again, you may go, again it's an iterative process. You can go back to the previous step and then you can again pick up cards. Though it looks so linear in the entire protocol, actually it's not, right. So, you can go to any step. What actions trigger the thing? Explore what type of input are needed, whether they are human actions, sensors or services, right. So, whether there is a physical human action, right. So, because many times your triggers, the sensor may not give you the trigger, you actually need a human action for that particular trigger. So, whether there is so you need to very clearly talk about whether it is a human action or a sensor or a service from a connected source. A thing can have multiple triggers, right. A thing can have multiple triggers and same trigger can affect multiple things, right. So, so a thing can have multiple trigger and the same trigger can again affect multiple things. Place your selections on the card placeholder in the trigger section of the board. How does the object respond to when it is triggered? So, when how it actually object responds to when that particular trigger happens. Responses allow the object to communicate back to the user when it is triggered, either by direct feedback from the object itself or by sending data to an app or service through services through services. So, through service component you are sending data to the server, right, as a feedback. So, that becomes your responses section on the board. So, all those feedbacks will finally go to the responses section of the board. Then comes flesh out the idea. The storyboard section of the board is your sandbox to describe and illustrate the idea you are working on. Finally, so from designer I am going to get a storyboard. So, we actually give them the sheets, so where they actually draw and do the entire storyboarding. So, flesh out the storyboard section of the board is your sandbox to describe and illustrate the idea you are working on. Try to make notes and sketches to show how, where and when the concept works and looks and what it might feel like to use it. Imagine a story which depicts a use case for your object. You can sketch each step on a post-it or stick them in the boxes, right. So, we have also provided them the sticky notes and different other materials. Reflect and improve. Look through different criteria and discuss how well your concept scores on each, right. So, now you have the criteria cards. Those are the filters that you are going to now put and then check, right. So, discuss how well your concept scores on each. Select a few strengths and weaknesses of the concept and see if you can come up with the improvements. To resolve the weaknesses, you can change and other cards and the storyboard if you feel the need. Write down the brief description of the final idea in the elevator pitch box. So, final is the elevator pitch box. So, from the storyboard finally you get the elevator pitch box. Yeah. So, these are reflection cards. I am just showing you the reflection card first, on the basis of which we were evaluating the concepts. So, first reflection card is the context awareness. So, so we are just trying to understand that. So, ability of a system or a system component to gather information about its environment at any given time and adapt behaviors accordingly. For example, how your smart home products sense the environment and provide services accordingly. So, that may be the context awareness. So, whether your PSS recognizes the context, that in what context you are using it, right. So, whether because you expect that your all the entities of the smart home should understand in which context you are using that particular product, or the lighting system in your home in the morning, in the evening, or maybe in the late evening, right, or maybe in the late afternoon, you expect to be different, right. When you are having dinner and when you are watching TV, you expect it to be different. So whether your system is being able to understand those contexts, whether your system is capable to understand whether it has the awareness for the context. Multifunctional, capability to perform more than one function, right. So whether like in your day-to-day behavior, you find that one particular object actually performs multiple functions, right. So whether the system that you are developing, whether it is being able to do multiple functions, like ability to cooperate, right. So whether the PSS that you have designed for in the context of smart home, whether it is being whether it is able to cooperate, right. So to work with other products to achieve a result what is beneficial. So whether the compatibility with the other product is there or not, whether it is being able to communicate with the other objects or not. Is your smart home being able to communicate with other SSPSs? Personalization, tailored products to accommodate a specific individual or a group. If whether your PSS allows your user to go for some amount of personalization, whether the degree of customization is there or not, and whether some amount of personalization it is allowing or not. The question is in how to judge is your SSPSS able to understand your mood and feeling and being able to alter the environment accordingly, right. Accessibility, openness is the accessibility of knowledge, technology and other resources and transformation of actions. How to judge, is your smart home product able to detect and connect with other SSPSs? Would your other smart products be able to perform tasks by a single command, right. So that is the openness, right. So whether it is only restricted to your kind of thing or it is more open. So these were the criteria cards that we developed. I don't have much time. I'll just quickly show you the other cards. Like these were the mission cards that we have developed. That is so the cards say independent, adaptive, reactive, human-like interaction, personality, interpretation, proactive, self-description, collaboration. So these were the mission cards. Basically, those define the goal of the entire exercise. Benefit cards, we created benefits card like the health related benefits, environment benefit, financial benefit, psychological well-being, social inclusion, luxury and status, resilience, technological enthusiasm, trust, safety and security, like she was talking about the trust, safety and security. Barrier cards with the technological barriers, financial barrier, ethical barrier, there can be ethical barrier, legal barrier, knowledge gap, psychological resistance, language challenges, lifestyle and resistance to control. These were the barriers that we identified, and on the basis of this we have created these barrier cards. Persona cards were like this: homemaker, husband, working woman, child, grandparents, meat cook, grocery shop owner, delivery boy, daughter, son. So these were the personas that we had created. Things card were electric kettle, gas stove, chimneys, modular dining space, refrigerator, pressure cooker, induction cooktops, kitchen weighing scale, microwave oven, right. I am just giving you some example: water purifier, rice cooker, food grain storage machine, toaster, deep fryer, storage for wet dishes, atta maker machine, cutting accessories, lunchbox warmer. So these were the different things that we had identified to be considered in the SSPSS design. So this was the, I am again showing you the toolkit. This was the toolkit, then this is how people work, right. So the final outcome was demonstrated like this. So we found, so if you look into this green buildings, no, so that so the blue portion is the without the tool. So again we experimented with a control group and an experiment group. We found that after using this Tiles IoT toolkit and this brainstorming game, people could actually come up with wonderful PSS design ideas in relation to the smart home. We could get very good ideas, and those were really implementable concepts, right? So, so this was on the basis of the peer review. We also then did a review from experts, so the industry experts who are into PSS, right? So who are into PSS, that too in offering different services to in smart home segment. So from there and from their viewpoint also, we found that this particular tool actually works effectively, right? So I conclude here. So the main learning points from this is that how do you understand the entire framework of PSS? So in your case, how do you identify different attributes of PSS? And then I have also proposed you set of different toolkits. Those can be useful for any PSS project that you do. I have explained you an use case where we have taken Tiles IoT toolkit as a reference, and we have tried to develop, we have actually modified the Tiles IoT toolkit in the context of smart home, which can be useful for a smart home designer, right? So I conclude here. Any question so far? No. Yeah. We don't have much time because the second session is going to start. Maybe we can take one or two questions.
So regarding the toolkit, what could be the limitations of this toolkit?
Yeah, so we have not, so first limitation, as I told you, is that though we are talking about the Indian context, our basic customer segment that we have decided is the people who are living in the cities, primarily in the metropolitan cities, that too in apartments. We have not considered different small towns or different villages, but we expect that the smart home offerings finally has to reach to the different segment, different geographic and demographic segment of this country. That was one.
Why is it so, like, why tier 1 only and why can't?
Because yeah, so we did some initial interview. We found that in the other segment, or maybe in the tier 2 cities or maybe towns, they have never seen a smart home kind of a scenario. So it becomes very difficult to do a user research. The people are not in fact aware of that this kind of things exist.
For the result that you displayed, for such experiment, what should be the sample size, and what are those slider indicating?
This slider is, so this is 0 to actually it was 0 to 10 scale, right? So this slider is actually indicating that sorry, not 0 to 10, it was 0 to 7, right? So this is basically indicating that how efficient it is in terms of perceived ease of use, perceived usefulness, context awareness, multifunctional, ability to cooperate, personalization, openness, and your service dominance design. So these were the attributes that we selected to evaluate the ideas, right? So sample size, it depends on this particular depends on the kind of experiment that you are conducting. So in our case, it was 80. In our case, it was 80.
And so suppose for the example, perceived ease of use. So
yeah.
it is 5.67. So how that number came?
That's the mean.
So
that's the mean value.
So the contestant was
like we administered questionnaires to the peers, and the we ask peers to rate. So we just exchange it also showed the statistical significance that the the rating was highly it was significantly varied between the control group and the experiment group. Thank you.
सेकेंड हाफ की अटेंडेंस लगा दो और
happening, although it's off. But
Yes, if you off this one, then there will be some frequency mismatch.
okay. Shall we start? Okay, everyone, welcome back to the course. So, in this particular lecture, I'm going to share with you a variety of cases of product service system in the industry. First, I expect you to be able to identify various cases from industry. All the cases that I'm going to share with you are taken from industry, which means that they are sort of, they exist in industry, meaning that they are viable, economically speaking, and other aspects as well. Okay, then I expect you to be able to describe some important business elements of different cases, because this will be useful in the upcoming exercise or project that you are going to undertake. And also, I have tried to group different cases into some sort of themes, although they are not sort of perfectly aligned, but I did try that. So that you will find some sort of common factors across different cases, across different sectors, because that's very useful to know, because you can apply such common factors to the case that you have at your hand. Okay. Start with let's say relatively common example. Taken from production machine industry. The core product in this case is a production machine, and as this visualizes, there are different opportunities to help the user of this production machine. For example, through spare parts provision, very traditional one, and then field service, remote service, hotline, and so on, and also training of the technicians and operators for those production machines. And you see, looking into industry, then you see a lot of these services are quite commonly provided. And one specific example from the sector is wear analysis, tear and wear happens, obviously. And it's very valuable information that to know the trend of the wear along the time. And this is very much building upon the digitalization, as we discussed earlier. And here, remote monitoring is a prerequisite for this service to be possible. Okay. And continuing with the same sector, another company offers services and also software upgrades along the lifetime. And in this specific case, the production machine can remain the same, and new software, new services can be added over time so that the overall functions of the machine can be enhanced. And this is an interesting thing, again related to the digitalization. In this case, software plays a very important role, as you can imagine. moving to another sector, truck industry. One truck manufacturer provides different types of services, as shown on this slide. And among others, I would like to highlight the fourth one, which is visualized the picture on the right-hand side. This truck manufacturer has developed a sort of system that works together with a kind of GPS, so that the truck can know the exact spot on the world, and that information is combined with another data source, which is about which geographical areas have some sort of speed limit restrictions. For example, pedestrian areas, etc. Like in this area, maximum speed is, for example, 30 kilometers per hour. So these two pieces of information are combined, and the sort of reasoning result is shown to the truck driver, so that it can be sort of automatically restricted in terms of the speed of the truck, or the information is provided to the driver so that he or she can decide the speed. So this case is also very much building upon the digitalization technologies and large-scale systems. Talking about a different sector, as I told you earlier, a service needs to sort of acknowledge the differences between different customers' requirements and also needs and wants, so that the quality of provided services can vary between different customers and users, depending on their specific needs. This case is very interesting in that aspect, because the company provides machine used in, let's say, milk industry, like pumping milk from cows and so on. And they acknowledge that the services, service recipient, i.e. who are farmers, no? The needs are different between different farmers, so that sort of customization, differentiation across different farmers is important. That is what they acknowledge, the company acknowledges. But if the company does that to such an extreme, then it becomes very inefficient and too much costly, right? So they acknowledge the importance of making a sort of standard for the services in terms of quality and also the procedure. Right? So I think this is an important sort of learning aspect in mind, so that when PSS and among other services are implemented in reality, they can be different, as I said, but you need to have some sort of level of economy to make the offering viable in terms of economy, right? And looking at printing machine industry, such machines are quite sort of availability sensitive. If they produce, for example, newspapers or other stuffs that are urgent for some cases, then the availability of such machines is critical. Therefore, this specific company of the printing machine producer provides, for example, full service contract that includes not only regular maintenance but also when something happens, or if and when the printing machine malfunctions, then a backup is provided to the customer, so that customers can ensure the printing availability, the printing machine availability, and also the availability of the outcomes of such printing processes. On a similar line of thoughts, a forklift truck manufacturer has a PSS offering, and which is provided through a sort of leasing contract where the ownership of the forklift trucks are maintained by the manufacturer, and the users of the trucks have access to the function and also the services. And it's interesting for this company saying in their advertisement that don't buy trucks, instead think about rental or leasing from us. Yeah, so these are the selling points from the forklift truck manufacturer's point of view, such as flexibility, higher flexibility, high preciseness of the cost prediction is some of the benefits of the customer of the PSS. This is also interesting from utility provider. The company provides electricity, heating, and so on. And they have a specific type of contract which is named comfort agreement. In this case, the provider makes an agreement with the customers in terms of the comfort level for the rooms used by the customer. No? So specifically speaking, so let's say we promise to keep your rooms at 21 degrees, for example. This is an example from Sweden, where it's much colder than here, and it's sort of critical. It's a survival issue in a sense, especially in the winter. So I think this is a type of contract that meets such a customer needs. No? Okay. And lighting. Typically, you may want to buy lamps, physical object, product. But in this case, you as a user pay for the lighting, where the provider fixes the lamps and also takes back the used lamps also. Right? Looking at the automotive sector, product as a service offering is available nowadays in different countries. This specific one is I think very, very relevant from this course point of view, because according to the published information from the company, product design has been adapted for this specific offering, and services are designed particularly for this product as a service offering, and they are organically connected with each other so that the monthly fee for using this service is decreased. So what is adapted in terms of product design is, so in this kind of contract, one user uses, let's say, for some time, 1 year or half a year, we don't know. But then the same car will be used through a new contract by a different user, okay? Which means that a number of contractors will use an identical car, and the customers may differ in terms of their needs and wants, so that products will benefit from the design for upgrades, because from one contract to another, the provider of this offering may want to change some function of the car at hand. Huh? And so that is implemented. And by implementing design for upgrade, the service cost is decreased. Right? So this is what I have been saying to you multiple times. There is an interrelation between product and services, right? And then they offer services using connectivity. Now they use effectively the digitalization techniques. The usage of the car could be monitored, and thereby the company can better prepare for what should be done at the end of the contract. When the car comes back to the company after the contract, then the company have already quite good knowledge about the usage history and thereby the expected condition of the car, so that they have a better preparation for the what treatments should be made for the specific car. So through these different elements implemented, the contract is decreased to some extent, according to the company. Right. And from now, in the coming several slides, I'm going to talk about turbine-related thing. The first one is about gas turbine. We, together with colleagues, wrote some specific historical development of PSS in the gas turbine sector. We know that some sort of aftermarket services, such as spare parts provision, training, and so on, have been provided historically. But let's say in the 90s, service-based solutions for higher increased customer value began, such as uptime-based contract and hassle-free operation, etc. And let's say around 2010s, they introduced condition-based maintenance services. And this is an interesting point. In order for the company to be able to provide condition-based maintenance service, they need to be able to predict some conditions based on the data and the information they can collect through a specific gas turbine in this case. And they need to be confident in saying to the customer, okay, Mr. Customer or Miss Customer, your turbine will is degrading and will fail in the coming months or so. that is a prediction requiring so much data and information. Because when the provider says that, of course, they need to do that. No? It's a promise. No? So in order to make sort of such a promise that requires cost and resource and effort from the provider side, they need to have a precise estimation and prediction of the machine. And that requires data and connectivity, etc. No? As you know, aircraft use turbines, similar machines, and Rolls-Royce is one of the well-known companies that have been active in the service offering, and the service-based sales is roughly half of their entire revenue. There is an interesting article by Smith 2013 describing the history of Rolls-Royce in terms of this specific offering, PSS. And this chart shows the horizontal axis is time over the years, and then the vertical axis is fuel consumption. And in the chart, different aircraft are plotted. And over the years, the fuel consumption has significantly decreased, as you see here. And because this is a result of their R&D activities. Huh? They have succeeded in improving fuel consumption. And it's not only fuel consumption. The other major quality they have managed to increase is component and part durability. So the durability has significantly improved, and therefore the spare parts business, which was a cash cow for them, has significantly decreased. So what happened actually is the company, the provider, invested a lot to improve their products and components and parts, and thereby they sort of made themselves suffering from the loss of the sales, which is the most profitable part. It's quite cynical, but this is when the company realized that now a business model must be switched. So that they started to offer sort of power by the hour scheme, meaning that they don't charge their customers based on the number of engines, but based on the hours of engine operation. So that if the engine lasts longer, it saves more on their cost. And the same article shows reduction of the cost. The dotted line is cost for the provider, whereas the thicker line shows the previous charging scheme, business model. It shows that the provider has managed to decrease the cost. And as a side story, when I was speaking with multinational company who is interested in implementing product service system, and I showed this graph, and manager sort of laughed at me. So the aircraft engine manufacturer lost their profit. So that's what the manager said to me. Yeah, I mean, the sort of direct interpretation of this graph is aligned with that. So the manager is sort of right. But think about what is not shown or what is not included in this graph. For example, the aircraft manufacturer keeps the ownership of the engine. After the contract, it's on their hands. It's valuable, right? It has value. And then they can, for example, sell the engine to another type of customers, etc. So this sort of shift of business models was initiated by the provider. Then we could assume that that shouldn't be bad for the provider. Huh? Any question? No? Okay. All right. There are examples in home appliance sector too. For example, vacuum cleaner is also under in the market, and also on the right hand side you see the heat pumps. One example is home appliance, for example, washing machines and other machines. This company has been offering this product as a service business since 2017. They started this business in the Dutch market. You can easily find this offering on the website. So their corporate report says that this offering started with their internal discussion about what they could do for circular economy. And so according to this report, through this business setting, product as a service, which is a special kind of PSS, they can keep the ownership of the washing machines and other machines, and they can make the important decisions that take place along their product life cycle. For example, typically washing machines come to the end of life after, let's say, 11 years, according to the statistics in Europe. And then the washing machine owners are expected to bring the machines bring the machines to the recycling stations. That's the sort of typical thing expected to happen. And then the recycling facility company decides what to do with the machines that are brought by the end users. But that type of company is not a specialist in making the washing machines, right? They are specialized in handling the sort of end-of-use products. But when it comes to this type of company who has the design data, they have CAD files, CAD files, and also they have produced these machines. If they manage well, they store the data from the production data of each washing machine. And then in this case, if the customer allows, then the usage data is collected and shared by the provider, if the customer allows. So this company has a big advantage compared with other types of companies. So design data, production data, usage data, well, basically, this company can collect and use the data coming from different life cycle phases. Huh? If you remember one of my slides shown earlier, so data and information coming from different life cycle phases can be used together to see correlation, for example, so that this company can make much better decisions than any other type of companies, right? The same company actually offers a variant of that business offering. This is, I think, especially interesting from business management point of view. So the provider is depicted on the left-hand side of this slide. They provide washing machines and other home appliance equipment. And the users in this case of target are special people who are vulnerable in terms of economy. So they typically don't afford to buy machines that are, for example, energy efficient. So they tend to buy cheaper products of the same kind, and such products are typically not energy efficient, for example, and meaning that they tend to decrease the upfront investment cost, but somehow they tend to pay more probably in the use phase because of the inefficiency of the use phase. Huh? So here, the interesting part is a special type of organization is involved. This is an offering from Belgium, so it's written in Belgian language. But the mission of this specific company in the middle is to help such socially vulnerable people. So the manufacturer involved that special organization in the middle so that the manufacturer provides washing machines to the special organization in the middle. And in this case, this organization keeps the ownership of the washing machines and make contracts with the end users. And typically this contract lasts for 10 years, and they charge a flat rate, monthly fee to the end user. There are, these are the roles of the three actors involved, as I explained. And each actor benefits from this constellation. As I said, the end user of this kind will benefit from lower energy bills, monthly bills, and meeting, of course, basic needs. And the social organization in the middle meets their own mission, and the manufacturer contributes to the social and environmental sustainability. So in order to help envision and design this kind of offering, this course is not specialized in that area of knowledge. We can research on this. I think there is a big opportunity in doing research for how to support coming up with these kind of new business models, right? Okay, continuing with washing machines, I would like to bring a case from Swedish condition. In Sweden, it's quite typical. If you live in an apartment, apartment building has typically, I don't know, a number of many apartments, families. And typically in the basement, there are washing machines which are shared by those many families. And typically there is a sort of booking system so that each family can make a booking to access to the washing machines. And now, interesting comparison is, as I said, this one is a sort of shared model, and it's not product ownership model. So it's a sort of PSS. And on the other hand, there is, of course, a traditional business model which sort of in which products are sold and transferred, the ownership is transferred to end users. So individual use of retail machines. The difference is, one major difference is the number of users per machine are different. No? And it's likely that the PSS in this case is more efficient in meeting a certain number of users, right, per machine. And then another important aspect here is the machines in this PSS are semi-professional machines in terms of size and also durability of different components of the washing machine compared with the typical machines sold in retailer shops. We did a sort of calculation, including simulation, in terms of CO2, considering the climate impact. So over the years, this is a result of long-term simulation. Over the years, we compared the CO2 emission from the individual use of retail machines that you saw on the right-hand side of the previous slide. And the green one means sharing semi-professional machines that you saw on the left-hand side on the previous slide. So we show that there is a significant difference in terms of CO2 emission between the two models, right? And here, interesting, another scenario is sharing, but using the retail machine model. So it's in between the two models. And that one is only a little bit better than the individual use of retail machines by individual users. So meaning that the difference between the middle scenario and the lowest scenario comes from the difference of the product quality. Okay? So again, this example shows that the such contribution in terms of CO2 emission reduction was caused by the service model as well as changes into the product design. Okay? So thereby, such a significant effect is realized. Okay? One thing I should mention regarding this case is governmental policy actually did play a role in Sweden for that kind of shared washing machine model emerged. I refer to this book. It's written in Swedish, but the washing machine room, a Swedish history. According to this book, there was indeed sort of the national regulations that influenced and supported the real estate developers to have this kind of common washing machine rooms. So this is sort of coming beyond the territory of traditional product design. Usually this kind of policy matters are given, and product designers don't sort of think about, don't question, and they just take them as given, and they draw the system boundaries by themselves, right? But this is interesting because this played a role for the washing machine sharing model as one design solution. So obviously, without this policy, it's likely that another solution was more popular. Huh? So it's an interesting example to see the policies could influence on the PSS solutions. So, 2 slides you will see. Related to the role of the product provider can change. So this case, the company designs, delivers, and operates assembly in a certain production line. And interestingly, according to the paper, Meyer et al. 2010, this company is indeed a part of their customers' production chain, production process. And the offering by this company to the customer can be seen as a result-oriented business model, meaning that a certain result is promised by the customer. Exactly same type of story is found from a different company. I refer to a different literature. And then in this case, exactly similar thing happened. So the company manufactures sort of films for the surface of TV sets like this, no? Surface part. But those kind of components have become commodities, so that the company sort of gradually lost their competitiveness. But in this case, the company got more involved in the customer's production process, which means the customer is, in this case, a TV set manufacturer, the final assembler. So they got sort of involved in a particular part of the customer's production process, and then they got responsibility for that part. And from the customer's point of view, they could decrease their production cost, and also the customers became so much dependent on this provider. So in this case, the company provided services which are sort of helping the customer's production system. That service has become so vital for the customers, and therefore the provider managed to make a very strong relationship with the customer. Right? Two cases are taken, one from Bangladesh, and the other slide, upcoming slide, from India. In emerging economies in general, the access to electricity is, of course, an issue. And in this specific case, the company helps people meeting this need. And they work on the electrification, and the company provides a sort of box, which is called solar box, and together with the solar panel, and they use interesting sort of electricity sharing scheme. One key factor that has made this business offering viable is microfinance institution is involved, and this feature is common to the case that I explained from Belgium, the washing machines provided to the socially vulnerable people. In that case, also the flat rate monthly cost was sort of maintained minimum, thanks to a middle organization. And then the similar, very similar thing was one of the success factors of this business offering. And the other case I mentioned is from SKF. It happens to be a Swedish-based company. It's a traditionally it's a bearing manufacturer. There is a case description of this company there through this link. But more visually speaking, in some cases they provide a service focusing on the performance. So this example shows that this kind of product service system can happen in this country. So I think this makes the course even more interesting. So the last slide. So from the paper by Van der Merwe, more than 30 years ago, it's interesting that there are sort of a common factor that we can see from different examples. And we can see a shift from things-based solutions or object-based solutions up to activity or experience-based solutions. So if you look at the left and right as a pair, so instead of providing bearings, a company can think of providing trouble-free operations. It's an activity and experience. So there are a number of examples of the same kind. And I think this can sort of trigger you to think of what directions a product-based offering can be shifted. Okay. This is really the last slide of this lecture. I'm quite sure that you know of this story. Apple managed to be very much successful by not focusing on the phone, but thinking about the surrounding products and services and systems. And an interesting story is from Sweden is Ericsson is a telecom manufacturer. telecom system manufacturer and also service provider. And I cite an article on the website, on a website, saying that internally they tested, I think it was iPhone, no? Internally tested the functions and the performance of the phone. And the conclusion was, this product is not good. So that was the conclusion. But, you know, the product is not the only element that determines the success of the business. No? So in this case, as you know, Apple managed to design other elements as well in such an organic manner. And this is, I think, a very good lesson for you to think about PSS design also. With that, I am happy to take any question that you may have. Yes? Washing machine.
One of the first with the flowchart. Yeah, this one.
This one.
So, so we can see how this will indicate success. I mean, it's a
Yeah.
that kind of an idea. So, I was wondering where the human factor comes into the picture, considering the end user in mind. Because while this looks like it will work, how do we know what the users, if they would accept this or not? Like, so if you take the sharing washing machines for that as the example, it does look like it would work.
Yeah.
But then how do we know that if people are willing to share?
Yeah.
How do we even predict what their behavior would be?
Great question. So if you didn't hear well, so the question is about how does a designer know, how can he or she know whether a certain, let's say, blueprint of a business model can indeed work or not. And her question was focusing on the users aspect, how users in this case, end users in this case, could react to this kind of business offering. And that is, I would say, a fantastic question. And I would say, I can say a few things. One is, so it's necessary to test with real users, huh? Say with a prototype or trial, things like that. Another answer is conceptual design that we are mostly addressing in this course so far is sort of aims to provide an organized way of making decisions, which sort of doesn't promise the success of the business, of the design outcome. There needs to be a specific step where the design outcome must be tested. Huh? And that's, of course, business-wise, very important step. But I would say what is equally important or more important perhaps than that is how to support designers in the process of coming up with possible solutions. That's why so far at least this course has been focusing on that part. Yeah.
Sir, can you go to the slide where we were talking about CO2 emission versus time? Yeah. Sir, so what is status quo there?
Status quo. This is simulation based on the current number of washing machines used in different models. So it's a mixture of, I would say, it's a mixture of this one, the blue one, and the green ones. Huh? Yeah, so it's sort of reality at the time of the start of the simulation. It corresponds to the reality.
Sir, in case that you have shared the example of Rolls-Royce, so what kind of business they are having if we plot something, some graph like this? Like what kind of business they were having? The newer business where they are lending the engines per hour uses. So what kind of business, like is it a share retail or individual, like that?
Yeah.
How do you categorize?
If I understand your question correctly, it's so the prediction in terms of time is a forecast based on the current state. Current state is building upon several business models. One is an individual buys a washing machine and he or she uses it at their home. Huh? And then another model that is included in the current status is the green one. So multiple users share a machine, huh? And a semi-professional machine. Huh?
So what was the model they have? How do you categorize the model of Rolls-Royce? Like the ownership they had, but they are just lending the aircraft for the uses. So what does that called?
For this one, the green one, the shared machine, or in this case, on the left-hand side, typically an apartment owner pays a monthly fee to a corporate. The fee includes the usage of the washing machines, access to the washing machines as well. Typically, it includes other stuff like heating and water and so on. So in a way, you can say that the model is, let's say, flat-based contract to access to the washing machines. And in this case, typically, the number of washing cycles per a family is not sort of limited typically, but in some cases there is a limitation. Okay, you can use the washing machine room, let's say X times per month or so. There is such a limitation in some cases, but basically flat rate and giving access to the washing machine function. That's the model. Yeah. Yeah. Take the microphone, please.
Could you please explain?
Explain again.
Yes, this statement.
Which part of this case?
So circular economy and like how the ownership is a profitable business. Like if the money is at the top priority.
So this is a statement in the company's report. This is what the company says. And the company sees this offering as a way for them to contribute to realize a circular economy, right? So this is the starting point. No? And I think your question concerns the economic aspect also. For example, the fee set to this specific washing machine costs, say, 25 euros per month. And you can check different fees for different machines and also different contract lengths typically the shorter contract costs more per month. And this offering has been on the market for 7-8 years already, meaning that there is a certain level of economic viability. And to how much profitable, it's, well, extremely difficult from outsiders' standpoint. And yeah, more question? I mean, yeah, I'm not sure if I answered to your question.
Like along with the repair, maintenance cost, and transportation costs. So still, having the ownership is it a profitable business? Like, you know, with which you mentioned yesterday that money is at the top priority. So with transportation and repair cost, maintenance cost.
Yeah, this fee turns to be a revenue for the company, right? And then, as I explained with one of the cases in an earlier lecture, the life cycle cost for the company consists of a number of activities. Getting a washing machine on place is one, and as you said, logistics is another, and preparing the service technician is another, and getting the washing machines back as a reverse logistic is another. Right? So there are different cost drivers. Right? And what the companies typically does is to collect data to calculate each cost driver, and then sum those drivers up and see if the revenue, expected revenue, is sufficient. Huh? We did a research work using a different product from different sector, and we showed that when a traditional product manufacturer shifts to a PSS business, often there are two factors that are sort of burdens, economically speaking. One is the overhead cost that exists as a product manufacturer, right? Each product manufacturer has its own overhead cost. For example, like indirect department, the company needs to pay the salaries for them, no? So such stuff. A typical problem is that kind of overhead still remains when the company shifts to a PSS business. Although the PSS offering doesn't fully utilize that overhead cost, right? So the business model is new for the organization, but when the business model is smaller compared to other traditional mainstream business, let's say, then the PSS offering must sort of bear the overhead cost as well. This is one factor. And another factor, obviously, is the additional service cost. Right? And well, this is obvious, but the key is, again, the service cost can be reduced by, for example, changing product design. This was achieved by the example that I showed in the automobile product as a service example. So that's why I think that example is very sort of pedagogical. Huh? Right. Okay, thank you.